Hello and welcome to Easy as Pie with Mr. Carpenter. I'm Mr. Carpenter, and this is the answer key. Where is my tools? There they are. This is the answer key for the review. Let's waste no time and get right into it. So number one, we have a line segment AB and line C are intersecting at point X, and X is in between AB. So if C is bisecting this line, which set of statements could be true? So we got a lot going on in our head. Let's translate that into an image on the paper. So we have a line segment, AB. So right there. And we have a line C that's bisecting this line segment. So bisectors cut things in half. So I'm imagining we got something like that going on. So there's line C. It intersects at point X, and it's cutting this line into two equal pieces. So which set of statements could be true? Well, let's apply all of them and see which one actually makes sense with this problem. So AB is 24, and AX is 24. Well, that doesn't really make sense. I'm expecting this to be half of the whole piece. AB is 16. And AX is 8, which means this other one will be 8, and this would make sense because part plus part equals whole, and this was cut into two equal pieces. So this does logically follow. Looking at the other answers really quick, AX is 4, so the other piece should also be 4, but it's 8. That's not right, and the same logic applies for answer D. Moving on, we have a diagram on the right. Which set of points are collinear? Collinear points mean they're on the same line. So A, F, and D, they're all points on the same line. Therefore, they are collinear. So it's got to be A. And finding the measure of angle AFB, well, that requires us to find out what X is and then apply that to the angle measure at the end. So there's a lot of different ways we could go about this. We can definitely find this angle right here because these are making a linear pair or they are supplementary angles. So they're going to have to add up to 180 degrees. So if that's 128, then this has got to be 52 degrees because 128 plus 52 is 180. And then here, I notice another straight angle. And I have three angles here that are adding up to this straight angle. I have this 2x and that 52. And then I also have this angle right here, and that's a right angle, so that's 90 degrees. All of those are adding up to make a straight angle or 180 degrees. And this equation that I can solve, we have 90 and 52 make 142. Subtract 142 from 180, it's 38. And if we divide, we should get 19. And do not fall into the trap of just circling A, because I didn't ask you for X. I asked for the measure of this angle, and that would be 2 times 19, which would be 38 degrees. Okay. Which statement is not always true? If it's not always true, we should be able to come up with some kind of counterexample for it. So for letter A, if two angles are supplementary, one of the angles must be obtuse. So two supplementary angles are two angles that add up to 180. For example, 90 and 95 and 85 are supplementary angles, because they add up to 180 degrees. So if we have two supplementary angles, does one of them have to be obtuse? Well, obtuse means we need one angle greater than 90 degrees. And the answer is no, we don't, because we could have two 90s adding up to 180 degrees, right? Two right angles. And neither one of them is an obtuse angle. So this is not always true. Letter B is just a definition. If two angles are congruent, they have the same degree measure. That is always true. Letter C, if two angles are complementary, so they're adding up to a right angle, in this case, both angles must be acute. Because in any case, I'm going to have to draw a ray in here that cuts this into two angles that add up to 90. And in all those cases, they must both be acute angles. And if we have a right angle, then the rays that are forming it must be perpendicular. That's a definition of a right angle, right? It's made from perpendicular lines. So that is also always true. Jumping in to number 5, we have parallel lines cut by a transversal. So we have these parallel lines. Name a pair of vertical angles. Vertical angles are created by the opposite angles of intersecting lines. So those are vertical angles. And those, those are also vertical angles. And they are always congruent to one another. So a pair of vertical angles, well, these are intersecting lines and these are opposite angles. So 1 and 4 would be a possible pair. You could go 5 and 8, 3 and 2, 6 and 7 are also possibilities. Alternate exterior angles. So the exterior, so this is the exterior, and then the inside of the parallel lines is called the interior. So alternate exterior angles, well, they're going to be on alternate sides on the outside of the parallel line. So, for example, angle 1 and angle 8. So they're on the outside, and they alternate left and right on that transversal, and they are a congruent pair. You could have also went with angle 2 and angle 7. Keep in mind, this could have been alternate interior angles. It could have been corresponding angles. It could have been same-side interior angles. So make sure you know all of them. If angle 2 is 40 degrees, go ahead and fill in the other 7 missing angle measures. So one path you could do is start with supplementary and vertical angles, right? These are vertical angles. They're congruent. So that must also be 40. These are supplementary angles because they're making a straight angle. So this must be 140. And then there's another pair of vertical angles. So that's 140. How do we transition down? Well, there's a lot of paths. You could see the alternate interior angles. They alternate, and they're on the interior of the parallel lines. They're congruent, so that must be 40 degrees. Or you could see alternate exterior angles, and they must be congruent, so that's 140 degrees. And with that, you can fill in the rest of the angle measures. So, done. Number 6, I have 2 angles. They're complementary, so they're adding up to 90 degrees. If angle A is 6 less than 3 times the measure of angle B, what are the measures of both angles? So I know nothing about angle B, so I'm going to call that X. Now, angle A is 6 less than, so I know I'm going to subtract 6. Then 3 times, I'm going to multiply by 3. Right? So it's 3 times the measure of B, which I'm calling X. So I can call that 3 times X. And it's 6 less than that. So minus 6. And these 2 angles are adding up to 90 degrees because they're complementary. And that's how I'm going to build my equation. Combine like terms, add the 6. Didn't mean to cross this out. I'm just moving it down where there's space. Divide by 4, and 96 over 4 is a number that is 24. So X is 24. I can use it to find the measures of both angles. Remember, we are answering the question. So angle B, well, that was X, so that is 24 degrees. Angle A, that's 3 times 24 minus 6. That's a 7. And that is 66 degrees. And those are my 2 answers. Number 7 is a construction question. There is going to be a construction on this exam. It's very tough to do this on the iPad, unfortunately, because I don't have a compass tool. But the idea with the compass is we're going to put the needle on B, extend it out to more than halfway, and draw ourselves a circle. I'm going to try my hardest. So I draw a circle there. And I'm going to keep that same length. So the needle went out this length. I'm going to keep that same length of the compass. And now I'm going to put the needle on C and draw that same circle. So it's going to go out that same length that the other one went. Ooh, good heavens. I'm going to draw another circle. Sorry, that was bad. Scroll up a little bit. Your two circles will have two intersection points. And if you use your straight edge to draw the line in between, they will intersect at a midpoint and create two congruent pieces. Yeah, I'm sorry it's so tough to see that without the compass, but that's the idea. Keep the length and move it over. Number 8, fun one. In the following diagram, CD intersects AB at X, and EX is drawn in. So the big question is CD a perpendicular bisector? Oh, there we go. Bisector of AB. Okay, so if you're going to be a perpendicular bisector, spelling hard, spelling difficult, you got to do two things, right? You got to be making a 90 degrees, making a 90-degree angle, and you got to cut your segment in half. You got to bisect the segment. So we're looking at this line here. Is that doing both of those things to this line? Well, let's look at the bisector part. Is CD cutting AB in half? The answer is yes, because X is told to me it was a midpoint. If this is a midpoint, then these are equal pieces, and this has no choice but to be cutting it in half. So yes, it is cutting the segment in half. Is it doing so at a right angle? Well, angle CXE is 34 degrees. Angle EXB is 54 degrees. By segment addition, these should add up to 90 if my hypothesis is true. And they only add up to 88. So they do not add up to 90. So this is not making a 90-degree angle. And CD is not a perpendicular bisector. For that reason. Because it does not or doesn't intersect at a 90-degree angle. So is this thing what I'm claiming it to be? Well, I'm going to apply the definition. What do I know about perpendicular bisectors? What do they do? What do they look like? And I'm going to use the information that I have in my drawing to see if that's actually happening here. And that's how I'm going to justify my stance. And that is the end of this review. Thank you very much for watching.